Hello everybody, this is Cameron Snow with Danomics. So in this video, I want to review our fluid substitution modeling capabilities. This is one of the more advanced capabilities that we have in Danomics. So before you start to approach this, it's critical that you get a good interpretation on your porosity, your water saturations, your clay volumes, and other properties. You'll also need to go through and have already calculated your synthetic shear logs if you don't have measured shear, as well as your rock strength properties. So the way we access this is we come here to the fluid substitution modeling in the drop-down list. And what this module does is it has a few different calculations, but its primary objective is to show you how the modeled uh, or to show you the variation between a measured and a modeled DT and DT shear as we change the fluid saturations. So for example, here I have the Lewis formation being shown. This is predominantly shell here, and then we have some sandstones in the Teapot and Parkman. And I'm going to focus on these here. And so the question that we would be asking is, hey, given what I know about the system now, about the oil gravity, the gas gravity, the porosity, the saturation, what is our, current understanding of VP and VS look like through here? And now let's say that I want to know what it's going to look like if I think it's a gas, if the target saturation is say 20%, that the gas gravity is, let's say a bit lower. Um, and what that allows us to do is to come in and analyze where we may see some of these subtle changes in here. And this will give us a clue on whether or not, when we're looking at our seismic data, if we would expect to see any type of change in amplitudes, for example. Now, when you are looking at this module, like I said, it's key that you've already looked at a number of other interpretations. This is so that you will understand the lithology, because you're going to have to come in here and choose which Voigt-Russ-Hill model to use. And there's also a number of cross plots that you will go through here, such as you'll want to understand your K-frame versus your bulk modulus. And here we can see in the shalier formations, this really is pushing off to the right. These are actually some sands that I've done the laminated sand analysis on. We'll want to look at the shear modulus versus those same properties, so we can see how that's changed, to give us an understanding of how our bulk versus shear modulus vary. And we can see, hey, what's going on here in the Parkman formation versus, let's say, the Sussex and Shannon, which are significantly shalier. So we can really start to see some separation between those formations, so we can understand what's going on there. And we also can look at things like, how does our V clay change relative to our bulk modulus? Once again, the sands and the shells are really starting to show some separation here on these types of cross plots. All right, so that is it for this very brief introduction to this. Once again, this is a quite advanced module, even though it has relatively few parameters that need to be set in it. So as you're going through your interpretation, if you're going to be integrating with seismic and you want to understand how compressional shear wave velocity may change with fluid saturation, this is where you would come to help understand that. All right, if you have any questions, you can reach us at support@danomics.com. Thank you.